Hi, in this lesson, we need to look at the risks posed by volcanic ash in the Cascade Range of volcanoes. This photograph taken after the 1980 eruption of Mount St. Helens shows perhaps some of the extent of the problem. But we need to look at it on a regional scale. Now for this lesson, we're working on page 15, questions 6, E, F, G, and H. Okay, let's go. This is the data that we have to work with. These are hazard maps for the Cascade Range of volcanoes. And it's looking at the probability, or the annual probability, should I say, of volcanic ash deposits of different thicknesses. So on the left, we've got the hazard map for a 1 centimetre ashfall from an eruption in the Cascade Range from Mount St. Helens. You can see it's quite an extensive area that's covered by this relatively thin ash layer. On the right hand side, we see the hazard map for a 10 centimetre ashfall. This, remember, is an annual risk. Now we need to try and assess the extent of this. To help you with this, we can look at the shape of these different hazard zones, and we can see they're sort of roughly circular. Clearly, the wind direction would have an influence on the distribution of ash. Remember, this is a coastal area. Wind is most likely to come off the sea onto the land. But it still gives us, certainly for the hazard map, a relatively circular distribution. The questions ask you about the 10 centimetre ashfall deposit. You can see that one, though it's roughly circular, isn't a perfect circle. If we're going to use an equation to work out the area of this, we need to use pi r squared. But obviously we haven't got one radius. We have, here I've shown diameters of different lengths. If we measure these diameters and work out the average diameter of this, and from that then the radius of the circle that would be equivalent to this, we can then work out the area that's covered by this 10 centimetre ashfall. Once you've worked on that, there is a digging deeper, looking at a volcano in southern Oregon called Crater Lake. Crater Lake is a caldera, so we don't see much of a volcanic cone, but we can see this crater lake, after which it was named, in the middle of this image, where the volcano collapsed in on itself after an enormous eruption 7,500 years ago. Just to give you some idea of the scale of what we're looking at here, the diameter of the crater here is about 10 kilometers. Okay. Bearing up that information in mind, we can see the extent of the ash deposit that's been detected, both for 30 centimetres or more than 30 centimetres, and also for 15 centimetres thickness of ash across northwest America. If you want, have a look at the atlas to see how big an area this is. Anyway, it's now time to press pause and work your way through those questions. See what you can come up with. Okay then, let's have a look at this, at the answers to these questions. Let's start with looking at the hazard maps uh, for an eruption at Mount St Helens. Volcanic ash is a significant hazard. Well, we can see from this map that this ash can travel a very long distance, thousands of kilometers away from a volcano. The problems it causes on the way include collapsing buildings because of the weight of ash on the roof, significant breathing problems because it's so fine, contamination of water, uh, and killing plants and crops. It can also um, stop engines from working, whether that's in aircraft or uh, engines for ground vehicles. It's a very widespread and very significant hazard from a volcano. Now, I asked you to work out the area of the 30 centimetre, the 10 centimetre ashfall from Mount St Helens, or the likelihood of it. If we look at these two diameters, measure them, compare them to the scale, it's about 480 kilometres long and about 345 kilometres wide. If we then work out our average, first of all, our average diameter, that's 413 kilometres. Remember, we're working to three significant figures all the way through here. If we divide that by 2 then to get the radius, that gives us an average radius here of 207 kilometres. If we put that into the equation for area, so pi times 207 squared, we get an answer of 135,000 kilometres squared. Just to put that into some perspective, Wales has an area of about 20,000 kilometres squared. So we're talking about an area nearly 7 times the size of Wales. It's a significant issue. And this, remember, is 10 centimetres of ash. If we look at the probabilities here and what these actually mean, let's zoom in a little bit. So this is the key to our map. Remember, these are annual percentages. So 1% is the equivalent of 1 in every 100 years. 0.1, 1 in 1,000 years, and 0.01, once in every 10,000 years. Showing the return period of depositing ash over that wide an area. Obviously, the longer in between eruptions, the more explosive they'll be, the more ash will get thrown out, and the further it'll get thrown out. Okay. For those of you that were digging deeper and looking at Crater Lake, we can see that the ashfall here is a much wider area than we saw with the previous volcano, and thicker ash as well. The reason for that, clearly it's a much bigger eruption. Now, if we calculate the minimum VEI for this, we need to work out the volume of this ash. So, again, if we look at the size of this area, if we measure it up, we get about 1,250 kilometres long and 968 kilometres wide. So to work out its average, we get an average of about 1,108 kilometres. So its average radius is 554 kilometres. So if we now work out the area of that ash deposit, put it into our equation, pi r squared, we get an answer of 963,716 square kilometres. Remember again, Wales is 20,000 square kilometres. 48 times the area of Wales. To work out the volume then, well, area times depth. We need to remember to not mix our units. Okay, so we've got the huge area by a very small thickness, 0.00015 kilometres, which is 15 centimetres. And we get a total volume of 144 cubic kilometres of ash. It's a huge amount of stuff. If you compare that with your VEI table, clearly we've got more than, we're between 100 and 1,000 cubic kilometres. So that eruption was a VEI 7. This as well, remember, is a minimum eruption, or a minimum amount of material that's been erupted, because we haven't taken any account of the thicker area of deposit by 30 centimetres, and also the 15 centimetre deposit that we have used. Well, it's 15 centimetres around that dashed line on the map. Inside that dashed line, it'll be thicker than that. So that volume we've calculated is an absolute minimum. It's actually going to be more than that, because the ash inside the circle will be thicker than 15 centimetres. Okay, as we see the sunset over Crater Lake, it's important to realise just how extensive a hazard the ash poses. The distance it can travel and the effects it can have are very significant and very long lasting. It's arguably one of the most significant problems that volcanoes can cause. Okay, we need to think about some other places that experience volcanic hazards, but that's for the next part of the lesson. I'll see you then.